So, good morning students. This is lecture 2 of chapter complex number. Now, in the previous lecture, we have discussed the different set of real number, a characteristic of real number, and what is the necessity for developing the concept of complex number, and now and the imaginary number iota. Now, in this lecture, we are going to discuss about the meaning of complex number. Clear? So, this is topic 2 of the chapter. Topic 2 of the chapter. Clear? Now, first of all, we will see complex number. Complex number. It is also called imaginary number. Imaginary number. In the previous class, we have discussed about the purely imaginary number. Now, complex number is called imaginary number. Now, which type of numbers are called complex number? So, the number which can be put in this form. The number which can be put in this form x plus iota y. Clear? The number which can be put in this form x plus iota y, where x is a real number, y is also a real number, and definitely iota is equal to what? Square root minus 1. So this type of number is known as complex number, and for representing complex number, generally we use z, omega. Clear? So let us denote this complex number by z. Clear? So any complex number has two parts. Real part, imaginary part. This part is free from iota, and that's why this part is called real part. Clear? So this part here, this part is known as real part of z and denoted by REZ. Now this part here is associated with iota. So this part is known as imaginary part here, and the coefficient of iota, this one, the coefficient of iota here with sign is called imaginary part. This is called imaginary part. The coefficient of iota with sign here is called imaginary part. Now, why is called coefficient of iota is called imaginary part? It doesn't mean that it is an imaginary number. Y is also a real number. Only its name is given imaginary part. Why? Because it is associated with clear iota. That's why its name is given imaginary part. But it is also a real number. Y is also a real number. Now, in general, complex number has two parts, real part and imaginary part. Now, if this part is 0, if imaginary part of complex number is 0, then z is equal to x. Clear? So, this type of complex number is given in a special name. Clear? If real part of z is 0, then z equal to iota y. So if this part is 0, z equal to iota y only. So this type of complex number is given a special name, and this type of complex number is called purely imaginary complex number. Purely imaginary also given a special name, and this is called purely real complex number. This is called purely real complex number. So in general, complex number has two parts. So if either of the part is 0, clear, it is given a special name. Now let us take example. Example 1. Example 1. Z equal to 2 plus 3 2 minus 3 iota. Now it is a complex number. Why? Because it is written in this form x plus iota y. It has two parts. Now 2 is a real number, minus 3 is also a real number. Clear? So it is a complex number. Now here the real part of z is 2 and imaginary part of z is minus 3. Clear? The coefficient of iota with sign is called imaginary part. So whenever you are writing imaginary part, don't write iota, only the coefficient of iota. Now z equal to, if I am writing only minus 3 iota, is it a complex number? So answer is yes, it is also a complex number. It can be written as 0 minus 3 iota. Clear? Where 0 is a real number, minus 3 is also a real number. So it is a complex number. Clear? Now here the real part of z is 0 and imaginary part of z is minus 3. Clear? Now this complex number has one part 0, real part 0. So this complex number is given a special name and this is called purely imaginary. Purely imaginary complex number. Imaginary complex number. Complex number. Now suppose we are writing here z equal to only 2. Is it a complex number? So according to the definition, if any number which can be put in this form. So let us put this complex number in that form. It can be written as 2 plus 0 into iota. So we can put this number in this form where 2 is a real number and 0 is also a real number. So it is also a complex number. Now the real part of z is 2 and imaginary part of z is 0. Now since this complex number has one part 0, so it is also given a special name, and this complex number is called purely real complex number. Purely real complex number. So from this example, it is clear that all the real numbers can be put in this form. Clear? So all the real numbers are also a complex number. So we can say that set of complex number includes set of real number also. So complex number is the biggest set of number. Clear? Which includes the set of real number also. So we can do each type of calculation here in the set of complex number, and that's what is complete set of number. Now we are going to discuss plotting complex number in graph. Clear? Or graphical representation of is a complex number and we want to plot this complex number in graph. So since it has two parts, real part as well as imaginary part, clear? So to plot this complex number we need two axes, clear? So take y-axis and this is x-axis. Now the real part of this complex number is plotted on x-axis. That's why this axis is known as real axis. Real axis. And imaginary part of this complex number is plotted on y-axis. That's why this axis is called imaginary axis. Imaginary axis. Now this is origin. Now to plot this complex number in this xy plane, clear? Represent this complex number in ordered pair form. Complex number can also be represented in this form. This is called ordered pair form of complex number. Now it is ordered pair, so position of components are important. First component always represent real part of complex number and second component always represent imaginary part. You cannot change the position. It is an ordered pair. So to plot any complex number in this xy plane, here, write this complex number in ordered pair form. Now this point, now plot this point. Here, plot this point in this xy plane. Clear? So this point can have 9 position only. This point can have 9 position only. Either it can lie in first quadrant, second quadrant, third quadrant, fourth quadrant, or it may lie on real, positive real x-axis, positive imaginary x-axis, negative real x-axis, negative imaginary x-axis, or origin. So let us suppose that this point has coordinate. Let us suppose that this point has coordinate x comma y. So this point will represent complex number z. So we can say that complex number is plotted by a point in xy plane. Clear? Now from point P, draw perpendicular on real axis. So this foot of perpendicular will represent the real part of complex number z. Now from point P, draw perpendicular on y-axis. So this foot of perpendicular will represent imaginary part of complex number z. Clear? Now, so when any complex number is plotted in this xy plane, clear? Now this plane is given a special name. This plane is called Argand plane. This plane is called Argand plane. Or you can call this plane as Gaussian plane. Gaussian plane. Clear? So when any complex number is plotted in xy plane, this plane is called Argand plane. The x-axis is called real axis and the y-axis is called imaginary axis, and the point complex number is plotted by a point. Now suppose we have to plot example. Suppose we have to plot this complex number 2 minus 3 iota. So where will be this complex number? Draw Argand plane. Argand plane is similar to xy plane. Now here the real part is can be written as 2 comma minus 3. So this point will represent complex number z. So where is this point? X is plus 2 and y is minus 3. 1, 2, 3. So this is real part, this is imaginary part. So this point will have coordinate what? 2 comma minus 3. So this point will represent complex number z. So this complex number lies in fourth quadrant. This complex number lies in fourth quadrant. Now take another example. Example 2. Suppose we have to plot this one. Z equal to 5 iota. Suppose we have to plot this complex number. So this can be written as, here the real part is 0 and imaginary part is 5. So this point will represent complex number 5 iota. Here. So this is Argand plane. Real axis, imaginary axis, horizon. So here the real part is 0. So real part is 0. This part will represent real part 0, and the imaginary part is 5. So 1, 2, 3, 4, 5. This will represent imaginary part 5. Here. So this point has coordinate 0, 5. So this point will represent the given complex number z. Now, so where does this complex number lie? This complex number lies on positive real axis, positive imaginary axis. This complex number lies on positive imaginary axis. Clear? Now similarly, suppose we have to plot this complex number z equal to only 2. Clear? So in order to form, it can be written as its real part is 2 and imaginary part is 0. So this point will represent this complex number. So to plot this complex number, this is real axis, imaginary axis. The real part is 2. So 1, 2. This will represent real part 2 and imaginary part is 0. So this will be the imaginary part 0. So this point will represent complex number z. So this complex number lies on positive real axis. Clear? So in this way we can plot complex number. Now let me see the time. Now we are going to discuss the important terms associated with complex number. So, important terms associated with complex number, or you can say characteristic of complex number. So any complex number is associated with three terms: conjugate, modulus and argument. So any complex number is associated with these three terms: conjugate of z, conjugate of z, second modulus of z, and third argument or amplitude of z. Modulus is denoted by mod z or by small r, and amplitude is denoted by arg, argument of z, or you can write amplitude of z. So these are the important terms associated with a complex number. Now we are going to discuss one by one. So let us discuss the conjugate of complex number z. So what do you mean by conjugate? So its definition is the image of z, the image of z in real axis is called its conjugate. It's called its conjugate, and generally denoted by z bar. So let us see here, if z is equal to x plus iota y. So let us see what will be the formula of z conjugate. Let us see what is the formula of z conjugate. So to get the formula of z conjugate, here let us plot z here. Suppose this is Argand plane, this is Argand plane. Here this x-axis is called real axis, this y-axis is called imaginary axis, and this is origin. Now to plot this complex number, plot the point x comma y. So suppose this point is representing complex number z. Suppose this point is representing complex number z. So it means from point P draw perpendicular on x-axis, this point will represent the real part of z, and from point P draw perpendicular on y-axis, this point will represent imaginary part of z. Now according to the definition, the image of z in real axis here. So take the image of this point in this real axis. X-axis is called real axis. So to take the image of point P in this real axis, treat this as a mirror. Treat x-axis as a mirror. So we will get the image of point P at the same distance behind. So this point, this distance and this distance will be same. Clear? So this point represents the image of z. This point represents the image of this point P. So according to the definition, this point will represent conjugate. So what will be the real part of this complex number? So from here draw perpendicular on real axis. This is the real part is same. So real part of any complex number and its conjugate is same. Real part is same. Now what will be its imaginary part? What will be its imaginary part? So from here draw perpendicular on imaginary axis, that is y-axis. So this will be minus y because distance is same. Okay, only the position is opposite. So its coordinate will be minus y. So it means if coordinate of z is x comma y, then coordinate of z bar will be x comma minus y. If its coordinate is x comma y, then its coordinate will be x comma minus y. So formula for z coordinate will be its real part is same. Its real part is same x. Now imaginary part becomes minus y. Imaginary part becomes minus y. So write here minus iota y. It means it is x comma minus y. So to find the conjugate of any complex number, keep the real part as it is. Change the sign of imaginary part. Only change the sign of imaginary part. Clear? So this is conjugate. For example, z equal to minus 2 minus 3 iota. Now we have to find its conjugate. Clear? So to find the conjugate, write the real part as it is, because the real part remains same. Real part of complex number and its conjugate are always same. Now change the sign of the imaginary part. Here imaginary part is minus 3. So write it as plus 3. Only you have to change the sign of imaginary part. Clear? See the second example. If z equal to 2, clear? It is purely real complex number. Here the imaginary part is what? 0. Clear? So what will be its conjugate? So write the real part as it is, and since there is no imaginary part is 0. So whether you write plus 0 or minus 0, it doesn't have any differences. So z conjugate will be 2 only. Clear? So here the same point will represent z and conjugate. Same point will represent z and z conjugate. Now one important point about conjugate here. When any complex number z is multiplied with its conjugate, then product is a positive real number. It is simple observation. Suppose z equal to x plus iota y and z conjugate will be equal to x minus iota y. Now when z is multiplied with z conjugate, so x plus iota y into x minus iota y, when these two are multiplied, it will be x whole square minus iota y whole square. So it will be x square minus iota square y square, and we know that iota square is minus 1, so x square minus 1 into y square, so it will be x square plus y square. And since x square is a positive real number, y square is also a positive real number, so it will be a positive real number. So when any complex number is multiplied by its conjugate, the product is always a real number. So keep this point in your